All right, hopefully by now you've tried these practice problems yourself, but here are the explanations if you need extra help. First of all, going through and assigning all the oxidation numbers. Chlorine is going to have a 0, iodine charge -1, molecular iodine is a 0, and the chloride ion is -1. So we see that the oxidation state of iodine is increasing from a -1 to a 0. So that's going to be my oxidation reaction, starting off with 2I- and yielding I2. Now we notice that we have 2 additional negative charges on the left-hand side, so we need to counteract those with negative charges on the right-hand side. So that's where I'm going to place my 2 electrons. This is the oxidation half reaction, and the electrons are being lost, produced. That all adds up. Then for the reduction half, we're starting off with chlorine and going to chloride. So we have Cl2, that's neutral, but the product side is these 2 Cl- ions. So we have negative charges on the right, we need negative charges on the left, so that's where I'm going to place my 2 electrons. This is a reduction half reaction, and the electrons are being added, gained, absorbed, what have you. So that also lines up. And neither of those coefficients will reduce, so that is the final answer. Next one, molecular zinc is a 0, copper ion charge of +2, zinc ion charge of +2, and metallic copper oxidation state of 0. My oxidation half reaction is going from zinc with a 0 to zinc with a +2. So we have metallic zinc going to zinc 2+. Now we have a neutral left hand, but right now an additional +2 on the right hand. So to get 0 overall, we're going to need 2 electrons here. +2, 2 negative charges adds up to neutral overall on both sides. Now copper is being reduced from +2 to 0. So Cu2+, and product is copper. Now this is the opposite of what we had before. The sum total needs to be neutral, so we need some extra negative charges on the left-hand half. Add in those 2 electrons, and now it's balanced with respect to charge. For the last one, we've got a few more species to deal with here, but we're going to go through an iron. This ion is +2. Oxygen is -2, so that brings us down to 4 times -2, -8 overall. But we only should have a -1 overall, so the manganese has to be +7. Now the hydrogen ion is +1. Here our iron ion is +3, manganese +2, and in water we have hydrogen with a nonmetal and oxygen -2. So we see that the iron is being oxidized from 2+ to 3+, while the manganese is being reduced from +7 to +2. So starting with the oxidation reaction, we have 5 irons, each with a 2+, and they're becoming 5 irons with a 3+. Now obviously 3 is greater than 2, so to make both sides equal, we need to add electrons to the right side. Now we have +10 total on the left and +15 on the right, so we need 5 electrons to balance it out. Now these all have a coefficient of 5, so we can reduce it to lowest terms and say Fe2+ yields Fe3+ plus an additional electron. Now for the oxidation half reaction, we know we need manganese, but the manganese comes bonded to oxygen. So the water is also going to be a part because that's the species with the oxygen, and that brings along with it the hydrogen, so we're going to have the hydrogen. All those additional species are going to be in the reduction half reaction. So we have manganese O4, negative charge, plus 8 hydrogens. It's going to yield Mn2+, and 4 water molecules. Now, in terms of our electrons, on the right-hand half, we have -1 and +8, so that's +7 overall, where on the other side, we only have +2. So to bring us down on the left side, reactant side here from +7 to +2, we need a -5. So we're going to add 5 additional electrons. And since nothing else will cancel out, that is your final reduction half reaction.